Hello there, and welcome to video number 200. This video is on frequency trees, and the keywords I've got for you are frequency, relative frequency, and experimental probability. Now the frequency is how much of something there is. The relative frequency is an estimate of probability, and the experimental probability is how you go about getting that estimate of probability. It's different to an expected probability. Now, frequency trees are used to record results when an experiment's got two or more steps. You can use these in place of two-way tables, two variables. So start with the total in a bubble and split it into two further bubbles that represent two outcomes for the first step. Split the two bubbles in two again and represent the two outcomes separately for the second step. The more you do this, the bigger the tree will get, obviously, quite quickly. So there's not going to be that many events that go on. There's probably just going to be those two events. Do it as many times as you need to, though. Interpret the question and put the numbers from it in the right bubbles. Use the data for the relative frequencies, which are the probabilities that you could get and calculate at the end of it. Now, question 1 asks us to, we need to fill in the probability tree here. 2 years ago, 100 GCSE maths students were asked if they would go on and study A-level maths. 25 said they would, 23 who said yes, did, and 7 who said they wouldn't actually did. Complete the tree. Now, what we have to do is figure out what goes where. All right, I appreciate I just froze then for a minute, but I'm back now. 100 is the total, and the total is always this bubble at the beginning. All right, so 100 goes in the first bubble. We need to split the 100 into two numbers, and 25 said they would. So you follow the branch that says yes, 25, and then 75 obviously is going to go where the no is. Those two add up to make the 100. Then we do the same thing here. 23, who said yes, did. So 23, carry on the yes, that's 23, and then 2 didn't. 23 and 2 makes 25, and then we have to look at the hardest sentence to interpret, I think. 7 who said they wouldn't actually did. So 7 who said they weren't going to, 7 out of these 75 actually did go on and do A-level maths. That means that 68 did not. Okay, those two numbers had to make that one. And that's all good, and that's filled in the whole frequency tree. So, pretty tricky if you just read the whole thing as one sentence, which is quite, don't pick out the key bits. Pick out the key bits, know where the numbers need to go, know these bubbles have to add up to the original one that they come from. Okay, that's going to help you out. Now, number 2, A, complete the frequency tree. B, do some more, and C, do something else. First of all, let's complete the tree. So 130, 60, this number must be 70. 70 plus 60 makes 130. These two numbers will have to make 70, so that must be 3. And then this number here must be 15. Easy to do that. Quick mental maths, you can work out what the numbers are. Because these two have to make that one, and these two have to make that one. Anyway, B, a student who said they wouldn't is chosen at random. So we're taking from the sample of the 60 people that said they wouldn't. What's probably that they did? So again, probably the same context as the first question about doing A-level maths. 45 out of them didn't, 15 out of them did. We want to know did 15 out of 60 it is then. Okay, so 15 of the 60 that said they wouldn't actually did, so there's our probability. We could turn it into a fraction, a simpler fraction, or a decimal or a percentage, but we don't have to because it's the world of probability, and that's fine unless it specifically asks us to. Now, part C, hence. The word hence means use the answer that you've just got from the previous question. Estimate the number who do if the number who said they wouldn't is 2,000. So instead of it being 60, the number that said they wouldn't being 60, it's now 2,000, right? So our fraction needs to have a 2,000 on the bottom. Okay, well, we know there was 15 out of the 60 that said they did. So if we do 2,000 divided by 60, right, we're going to get, let's just do that. So 2,000 divided by 60 is some random number, 100 over 3. And then we multiply it by the 15. So we're going to find an equivalent fraction. Just finding an equivalent fraction. We got 500. So if it was a sample out of 2,000 students that actually said, no, I'm not going to do A-level maths, we'd expect 500 to go on and actually do A-level maths. There you go. So there's that particular question. I'm just going to get rid of that working out there. So we've just got the answer in the answer space, and that's nice and neat and tidy now. Bit tricky, but hopefully doable, using these to get some probabilities and then answer some other questions off the back of it. Now, question number 3 is definitely a bit trickier. We've got 48 men and 36 women visit a restaurant. 72 of them have a voucher. 3 times as many men as women do not have a voucher. Complete the frequency tree. So there's some weird stuff going on here. We don't know some of the numbers, right? What we can do is we can add the 2 numbers that we've got there to get the total number. Okay, so 48 men and 36 women. 48 plus 36 gives us 84. So 84 people total were in that restaurant, visiting a restaurant. 72 of them had a voucher, so we can easily put that there. That means that 12 of them did not have a voucher. Okay, and we can do that on the calculator if we need to. 72 minus, 84 minus the 72 gives us 12. And then we've got this horrible sentence here. 3 times as many men as women do not have a voucher. This is a bit tricky, but what the information is that we've got here is 48 men in total were at this restaurant, right? That means that this bubble and this bubble, the first one and the third one, will add up to 48, sorry. The women, the females here, are 36. So this bubble and this bubble, the second and the fourth, will add up to 36. We just need to work out what's going on. So reading this sentence here, 3 times as many men as women do not have a voucher. So 3 times something and something. All right. So we're just representing the women with an X and the men with a 3X. We can form a simple equation here and solve it. So 3X plus X is 4X, and that equals 12 because these two add to make this one. Then we can solve it and we can find out that X equals 3. Okay, so instead of writing X there, we can now put 3 there. And remember that the men is 3 times more than that, so that's 9. 3 times 3 is 9. So 3 and 9, that makes the 12. That works, but it has to work here as well. So remember this male, 48 take away 9 is going to be 39. Don't know why I need a calculator for that. So 39 men there, and then this one, 36 women. These two add up to 36. So 36 take away 3 is going to be 33. 39 plus 33 should give you 72, which it does, and therefore we have done the question correctly. Everything adds up. It's all good. Definitely a trickier question, interpreting the words there and forming some equations, solving the equations, and then making sure you get the right numbers in the right places. That's probably going to be worth a good 4 marks on an exam paper. Right? Definitely a tricky grade 4 question. But hopefully it's helped you understand the world of frequency trees just that bit better. We got through 200 videos, and I think I've got about 15 more, 16 more to make, something like that. All right, so we're getting there, and yeah, keep watching. Cheers, guys. Take care. Bye-bye.